Hi everyone, welcome to another video. We're introducing a new concept in this video called the line of best fit. And this has to do with a lot of the things we've been working with so far in the realm of our scatter plots in the last few videos. So, just to reintroduce it, a scatter plot is any time we have this bivariate data that we talked about, two variables, and we can plot them on an XY plane to see if there's any correlation or relationship between one variable on the Y-axis and another on the X-axis. Now, we said in the previous few videos that how linear these are tells us how much they correlate, or the relationship, because the more they get bunched up together, sort of similar to what we have here, the more we can say that one thing relates to another, because there is a trend going all the way through. Now, this video, the line of best fit, is something that we can use to, when we see these types of trends happening in a linear fashion, we can draw in a line that roughly fits all of these points on our scatter plot. So I've got the one here, and it's really in the name. We want a line that best fits the data points we have here. So let's look at how we can do something like that. Before we do, let's just write a couple of definitions. So a line of best fit, I'll go LOBF for that. This is, can also call this a trend line. When we do this by eye, so looking at this and then roughly drawing a line, this line is positioned by eye. So we look at this and just roughly figure out where it should be by balancing the number of points above the line with the number of points below the line. Balancing the number of points above the line with those below the line. Okay, so if we look at these here, I'm going to roughly by eye draw a line that best fits these points. So let's do something like this, or maybe, and it may require you to have a couple of goes at it as you do it, because it is quite difficult to do by eye. But we can kind of see here that roughly we're passing through a couple of points. We've got this point here, this point roughly, and this one. And we have balanced the amount of points that aren't really on the line. So these remaining ones, so let's do another color. So this one, this one, this one, I have 3 above it, this one, this one, this one, 3 below it. So I have made a line that passes through some of these points, but roughly balances out all of the other ones. And this shows the rough linearity of my data set. And what this allows us to do is, once we have a line of best fit, we can come up with an equation of the line of best fit. So this is where some other topics start to come in. So things we've learned in linear relationships, that the general formula of a line is y equals mx plus B, some textbooks say C. This thing on the end is really just a constant, but we remember that based on these, our M is our gradient. So our gradient tells us how much one thing changes, one variable changes compared to the other. And here we have our y-intercept. And we're going to really revisit this a lot in the next video. We're mainly just introducing all the concepts that are going to be relevant to the line of best fit here, and then we're going to do a couple of practice questions in the next video. And in order to find the gradient, we remember we can take 2 points that lie on the line. So let's say this one and this one. Now let's call this point some arbitrary point x1, y1, and this one is going to be x2, y2. And in order to find the gradient, we're finding the rise over the run. So how much between those 2 points are we rising for each distance we run along in the x direction? So our gradient is our rise over run. And we find that by doing our gradient. We can find the difference between the y values, that's the rise. So I can say, for example, y2 minus y1, and the difference between the x values, so x2 minus x1. This is how we can find the gradient. And basically, once we have that, we can essentially analyze our data. We can make sense of it. So the line of best fit and the equation that we get for it can be used for what we call interpolation. So if you look at this word, some part of it here, interpolation, this kind of sounds like to interpret. So when you interpret, you're trying to make sense of something. But the interpolation part of this, when we analyze our bivariate data, has to do with constructing points within a given range. Within a given range. So what we mean by that is in the range where our data points lie, so from like all of these ones here, that is our interpolation. So we're using trends that we notice within the range of our points to interpret and predict other values of these points. So within those here, that's going to be interpolation. So we're basically using the linear trend to predict different values of different variables within this range that I've drawn up in this blue dotted line here. And outside of that, when we start to extend our data beyond, so outside of these particular points here, this is what we call extrapolation. So let's define it first. Extrapolation. This is constructing points outside a given range. So this is where we take the trends we have observed, so based on the linearity of our points on the scatter plot, we see how much does one correlate with another, and we use that to make predictions outside. So here where I've done this dashed line here, this is my extrapolation. So I'm working outside of the range of my points here. This guy down the bottom here as well is also extrapolation. Because I'm trying to find what's going on outside of my data set. So I'm trying to make predictions about things that are outside of the particular range. And we will look at how we work that in the next video. But this is just to give you an introduction into the line of best fit, what it means, how we use it in scatter plots, and how we can relate it to what we know about linear relationships already from our previous studies, and a couple of uses of this, interpolation as well as extrapolation. But we'll get plenty of practice with these in the next video. But thank you so much for watching, and I'll see you next time.